Have you ever wondered about astronauts? They float in space, they look like they have no weight. Does this mean they are nothing? Just empty spacesuits drifting by? This question seems simple, but it opens up big ideas. Ideas about what we are, and how the universe works. It's a cosmic riddle we can solve together. We often mix up two ideas. These ideas are mass and weight. They sound similar, don't they? Many people use them like they are the same. But in science, they are very different. One tells you how much stuff you have, the other tells you how hard gravity pulls on that stuff. Understanding this difference is key. It helps us understand space travel, and even our own world. Let's begin this amazing adventure. Let's talk about mass. What is it really? Mass is the amount of matter in an object. Think of it as all the tiny particles, the atoms and molecules packed inside you, or inside a planet or a star. It's the fundamental stuff of existence. Everything you can touch and see has mass, from a tiny grain of sand to the largest galaxy in the cosmos. The amazing thing about mass is constancy. Your mass stays the same, no matter where you go in the universe. If you have a mass of 70 kilograms on Earth, you will have a mass of 70 kilograms on the Moon, you will have a mass of 70 kilograms on Mars, or even floating in the emptiness between stars. The amount of you doesn't change. Your fundamental substance remains. Mass is an intrinsic property. Mass also has another cool property. It's called inertia. Inertia is an object's resistance to change in motion. The more mass an object has, the more inertia. Now let's unravel the concept of weight. Weight is different from mass. Weight is a force. Specifically, it's the force of gravity. It's how strongly a planet or moon pulls on your mass. So, your weight depends on where you are. It's a measure of that gravitational hug. Sometimes it's a gentle hug. Sometimes it's a really strong one. This pull is always directed towards the center of the massive object, like Earth. Your weight can change dramatically. This happens if you travel to different places in space. Why? Because the strength of gravity changes. Larger planets with more mass have stronger gravity. Smaller moons with less mass have weaker gravity. So, your mass stays the same. But the pull on that mass varies. This is the crucial difference between the stuff you are made of, mass, and the force you feel, weight. Let's use an example. You. On Earth you have a certain weight. Let's say you weigh 700 newtons, about 157 pounds. If you travel to the moon, its gravity is weaker. Section 4. The zero-G illusion, how mass floats free. So how can an object have mass but no weight? This happens in what we call weightlessness, or more accurately a microgravity environment. Imagine being far out in space, very distant from any planets or stars. The pull of gravity would be incredibly tiny, almost zero. In such a place you would feel weightless. Your mass is still there, all of it, but the force of weight is nearly gone. Now what about astronauts orbiting Earth? They look weightless, floating in their spacecraft. Are they far from Earth's gravity? Not really. The International Space Station, or ISS, orbits only a few hundred kilometers above Earth. At that altitude, Earth's gravity is still strong, about 90% as strong as on the surface. So why do they float? It's because they are in a state of continuous freefall. They are constantly falling towards Earth, but also moving sideways very fast. This freefall is the secret to their weightlessness. The spacecraft, the astronauts, and everything inside are all falling together at the same rate. Think about being in an elevator. Section 5. Adventures in weightlessness, real-life examples from Earth and beyond. We see mass without weight most clearly with astronauts. On the International Space Station they are a perfect example. They float effortlessly through the modules. A gentle push sends them gliding. They don't feel the pull of gravity as weight. Yet each astronaut has their full biological mass. Their bodies are still made of the same stuff. Their hearts still pump blood. Their muscles still need to work, or they weaken. This shows mass is present even if weight is not felt. Daily tasks on the ISS highlight this distinction. Imagine an astronaut trying to move a large piece of equipment. The equipment floats, so it has no apparent weight. You might think it's easy to move, but it still has mass and therefore inertia. Pushing it requires force to accelerate it. Stopping it requires force to decelerate it. If they bump into it, it will still resist. It won't fall to the floor because there is no down for it. But its mass makes it behave predictably according to Newton's laws. We can even experience brief periods of weightlessness on Earth. Special airplanes, sometimes called vomit comets, achieve this. These planes fly in a special path. They fly up steeply, then arch over, and then they dive downwards for a short time. During this parabolic arc, everything inside becomes weightless, for about 20 to 30 seconds at a time. Section 6. Clearing cosmic confusion, FAQs, and the grand summary. People often ask, is there truly zero gravity in space? The term zero gravity is a bit misleading. Gravity is everywhere in the universe. It's what holds galaxies together. What astronauts on the ISS experience is microgravity. This means gravity is much weaker, or they are in free fall. The ISS is constantly falling around Earth, so they feel weightless, but gravity is still there. It's about 90% of Earth's surface gravity. It's this continuous falling that creates the sensation. Another common question, if you're weightless, do you lose mass? Absolutely not. This is a key point. Your mass is the amount of stuff you are made of. That stuff doesn't disappear just because you're floating. Weightlessness is about the force of gravity you feel, or rather, the lack of that feeling of force. An astronaut in orbit has the same mass as they did standing on the launch pad. Their physical substance remains unchanged. Only their relationship with gravity has shifted. How do astronauts measure their weight in space? Since bathroom scales rely on gravity, they don't work. But doctors need to monitor an astronaut's health. This includes checking if they are losing body mass. So they use a special device. It's called an inertial balance or a body mass measurement device. This device applies a known force to the astronaut. It then measures how much they accelerate.